Here we are at the third set, and this is where we're going to see some neat things here. In the first column, we're going to see a situation called the ambiguous case, and we saw a glimpse of it in set 2, but now I really want to dive in and show you exactly what happens in certain situations. Here we're not given a triangle, so we have to draw one. If we start drawing the horizontal line and forming angle A here, we can start to see that a possibility for this triangle could be this. We could have side length A across from angle A, and we could have side length B across from angle B, just like that. We don't know the measure of side length C, but this could be a triangle. Another situation that could exist, if you think about it, imagine that this side length CB swung over to right here. Can you see there's a situation where we might have a triangle that looks like this, where angle B is bigger than 90 degrees. A is still 4, B is still 7, and A is still 20 degrees. But side length AB, or little c here, is smaller. We call the first version case 1, and the second version case 2. And all that means is we just need to provide measurements for each of those triangles. Now that did happen in set 2, where this side length here, 5, could have been right there. When we were figuring out the angle and we saw that that measurement was smaller than we thought, it was because we were getting the second case. We were getting another triangle essentially. But in set 2, the given information was a picture of a triangle. So they were asking you for the measurements of the one particular case and not the other case. And that's fine. You just have to realize that could occur sometimes, and you have to deal with it accordingly. In that example, when we used the sine law to find angle C, the calculator gave us 55.5 degrees. But when we looked at our drawing, we could clearly see that that angle needed to be larger. When it happens, just subtract that angle that you get from 180 degrees to get the angle that you need. When you're given a side, and an angle in the problem, and you have to draw the triangle, the angle that you know should go in the bottom left. The side across that angle should go there. And the third side known would be here. The side you don't know should be here. And of course, the two angles you won't know either. So again, it's the side, angle case where you're going to have the ambiguous case. One more thing you have to pay attention to is when you're given side, angle measure, and I believe the angle measure was 20 degrees given. Anyway, when you're given side, angle, that's where you need to make sure you consider the two possible cases. You also need to check the height of the original triangle from C down, form a 90-degree angle. We call that the height. We need to make sure that the given information actually does form a triangle, meaning is that A side long enough to complete the triangle? And how you figure that out is find the value of H. H needs to be the shortest side. A will be longer and B will be the longest. We say that H has to be less than A and A has to be less than B. How do you find H? We know in our example, angle A is 20 and B is 7. We could use the sine ratio. Sine of 20 degrees is opposite over hypotenuse. H is going to be 7 times sine 20 degrees. 7 times sine 20 degrees equals 2.39. H is 2.39. 2.39 is less than 4, which is less than 7. We have a complete triangle for sure. Here's what it would look like if we did not have a complete triangle. The A would be smaller than the H. We wouldn't have enough length to reach the bottom side. Let's work out both cases and we'll compare the measurements. We're going to need a lot of space, so we'll start over here with step 1, case 1. We could find this angle and that angle and then the third side. That would work. We'll find out angle B in the first triangle. Sine of B over side length B is equal to sine of A, or 20 degrees, over 4. Sine of B is 7 times sine of 20 degrees over 4. B is the inverse of sine of all that stuff. B is inverse 7 times sine 20 divided by 4 equals 36.8 degrees. For angle B, where am I going to write this? Shall I go here? Step 2, we'll find out angle C. 180 degrees, subtract 20, subtract 36.8 degrees. 180 subtract 20 subtract 36.8, 123.2 degrees. And that seems to be about right according to our picture. I think I'm going to write over here, even though we're not doing this one. Step 3, side length C. C over the sine of C is equal to A, 4, over the sine of 20 degrees. C is going to be 4 times sine of 123.2 equals divided by sine of 20 degrees, and we get 9.8 to 1 decimal place. 9.8 for C. Case 1. Angle B is 36.8. Angle C was 123.2. And side length C was 9.8. I'm saving it here because I'm erasing everything else. Let me see if I can make a visual here. I've got 20 degrees and B is 7 and A is 4. If we take side length A and swing it around, we can see the other case. Look at that. If the A is too short, we won't make a triangle at all. The A needs to be long enough to hit that other side. Shall we work on case 2? Step, what are we on, 4? Here's where we need to think a little bit. If you examine case 1, side CB and this red dashed line are equal, it's 4. Side A swings over and becomes side A over here on the dashed line. We know that angle B was 36.8. Therefore, we know that this angle is 36.8. And that's where we get 180 subtract 36.8 to find the obtuse angle. Angle B in case 2 must be 180 degrees subtract 36.8 degrees. 180 subtract 36.8, 143.2. 143.2 degrees for angle B. Step 5, we could find angle C. 180 degrees subtract 20 degrees subtract 143.2. degrees. 180, subtract 20, subtract 143.2, 16.8 degrees. Angle C is 16.8 degrees. Almost done. One more step. Side length C. C over sine of C equals A, which is 4, over sine of A, or sine of 20 degrees. C is going to be 4 times sine 16.8 over sine of 20. 4 times sine 16.8 equals, divided by sine 20, 3.4. Side length C. For case 2, angle B is 143.2 degrees. Angle C was 16.8 degrees, and side length C 3.4. Nicely done. Last one, let's tackle SSS. We want to get the side lengths right. I'm thinking it probably looks to be about right. The largest angle should have the longest side. That's okay. The other two might not match up. We'll adjust it after. We know we have 15 for little a, and b corresponds with little b, and c corresponds with little c. Cosine law, a squared equals b squared plus c squared minus 2bc cosine of the included angle, where the included angle doesn't have to be called A. I mean, we could call it C here and use these two. In fact, let's do that just to show you that you don't have to have the letters corresponding, because on a formula sheet, you usually just get one version of the cosine law. If we want to find out angle C here, that's not corresponding, but let's think about A as being the included angle between two sides, A, B, like that. Really what we're plugging in is C squared equals A squared plus B squared minus 2AB cosine of C. But you don't need to think about those letters, just think about included angle. We have 13 squared equals side 1, 15 squared plus side 2, 9 squared minus 2 times 15 times 9 cosine of C. We're looking for C. All of that needs to be isolated. We'll have 13 squared minus 15 squared minus 9 squared. And that means to get cosine of C by itself, we're going to divide by negative 2 times 15 times 9. What we do to one side, we do to the other. Those two make 1. Cosine of C is by itself. And now we need a calculator. 13 squared minus 15 squared minus 9 squared equals, divided by, start your bracket, negative 2 times 15 times 9, close the bracket, equals, that's the ratio. And now we need inverse cos. Inverse cosine of the ratio equals 59.5. C is 59.5 degrees. And we got that by using the inverse of all of this. Now, we forgot to even label step 1. We were trying to find angle C. Very important to label those steps, so whoever's marking your work knows exactly what you're doing. Let's move all this over. Now, step 2. We have an angle and we have 3 sides. We can find angle B. Angle B, sine of B over side length B is equal to sine of C, which we found to be 59.5, over side length C. Sine of B is 9 times sine 59.5 over 13. 9 times sine 59.5 equals, divide by 13, and use the inverse sign. 36.6. Angle B is 36.6 degrees. Step 3. Almost done. We just need the third angle, and hopefully angle A turns out to be larger than 90 degrees. Angle A is what we're looking for. 180 degrees, subtract 36.6, subtract 59.5. 180, subtract 36.6, subtract 59.5. Drum roll. 83.9. 83.9 degrees is angle A. Oh, our picture's a little off. If we start with B9, we want 60 degrees. We don't know how long that is. And then this angle's probably, I don't know, like that. B. This one's 59.5. B is 36.6. A is 83.9. Side length A is 15 and side length C is 13. That looks a little bit better. Don't panic if your triangle doesn't work out initially. You can adjust it after, just as we've done. Grab that eraser and get rid of it. There you go.